To follow up on the point that I made at the end of the previous video, let's just pick a little bit of a simpler example to look at, where we could say that f of x is going to be x squared minus 16 over x minus 4. And we're wondering what is the limit as x goes to 4 of f of x. So once again, we note that if we plug in 4, we get 16 minus 16 is 0 over 4 minus 4 is 0. So we have a indeterminate form here. But this one's even a little bit easier than last time. Limit as x goes to 4, the numerator factors as x plus 4 times x minus 4 over x minus 4. We have our unsurprising cancellation here. And the limit as x goes to 4 of x plus 4 is equal to 8. So just graphically what's going on here, f of x, x squared minus 16 over x minus 4, the graph of it is just a straight line with slope 1 and y-intercept 4. It basically looks just like x plus 4, with the exception that there is a hole here because f of x is undefined when x is equal to 4. So the only difference between f of x being this and a different function g of x as being x plus 4 is that our f of x is not defined at 4, g of x is. But once again, limits don't care about what happens at the point itself. It only cares about what happens nearby. And in both cases where we take the limit from the left and the limit from the right, we're getting closer and closer to 8 here. So this is the nice case. Remember, what's the term from before? We have a removable discontinuity. So in general, most of our most important cases here are going to be these removable discontinuities where we can just patch things up. Okay, so let's do some more examples where once again it's just going to be applying various algebraic manipulations in order to get things from an indeterminate form to something that's not an indeterminate form. What would happen if we had something like the limit as x goes to 5 of x minus 25 over square root x? That should be the limit as x goes to 25 of x, limit as x goes to 25 of x minus 25 over square root x minus 5. So realize what happens when we plug in 25. We get 25 minus 25 is 0 over square root 25, which is 5. 5 minus 5 is 0. So indeterminate form. So once again, we should be thinking about how to do some algebraic manipulations here. So take a moment, think about how you might handle this. So the best way to handle this is, well, there certainly are multiple ways, but maybe one of the more straightforward is that we've got a square root in the denominator, and so we can try to multiply by the conjugate. So we're going to multiply by square root x plus 5 in both the numerator and denominator. And so we're not changing, we're multiplying by a form of 1 here, so we're not changing what the limit is. And this has the advantage that the denominator, square root x minus 5 times square root x plus 5, ends up being x minus 25. You can check that for yourself. And so the numerator stays as x minus 25 times square root x plus 5. And oh look, life is wonderful. We can cancel out factors of x minus 25. So limit as x goes to 25 of square root x plus 5. And at this point we can just plug in. So this is continuous at x is equal to 25. Plugging in gives us square root 25 plus 5. That's 5 plus 5 is 10 for our final answer. So once again, we had a 0 over 0 indeterminate form, and once again, a small amount of algebraic manipulation is going to allow us to get it out of the 0 over 0 indeterminate form and into a place where we can use continuity and apply substitution. So that's another example. Here is another example where we have a different type of indeterminate form. So if we were asked for what is the limit as x goes to 1 of 1 over x minus 1 minus 2 over x squared minus 1. So now what happens when we plug in x is equal to 1 here? Well, this is going to be a 1 over 0, which looks like either plus or minus infinity, depending on whether we're taking the limit from the right or the left. And this term is also going to be a 2 over 0, I guess 1 over 0. This also looks like a plus or minus infinity, based off of whether we're taking the limit from the right or the left. And so we should be thinking about, once again, how to, because both the denominators here are 0, well, maybe in some way we're doing something minus something. Maybe we can combine this together in a way to get things to cancel out. And so the way that we want to do this is that we have one fraction minus another fraction. So the best way to do this is to combine those together into one common fraction. So note that x squared minus 1 is x plus 1 times x minus 1. And so this suggests that what we should do is that we should multiply the fraction on the left by x plus 1 over x plus 1, and this will allow us to combine our two fractions into one by putting everything over a common denominator. So let's go ahead and do that. So 1 over x minus 1 times x plus 1 over x plus 1 minus 2 over, I'll go ahead and write this out as x plus 1 times x minus 1. So at this point, everything is over x minus 1 times x plus 1. And upstairs, we have x plus 1 and then minus this 2 here. We can simplify the numerator to get x plus 1 minus 2 is x minus 1. And oh, look what happens. Once again, some magic cancellation happens, and we are left with the limit as x goes to 1 of 1 over x plus 1. And so now we don't have a problem when we plug in 1. This is continuous at x equal to 1. We can apply substitution. 1 over 1 plus 1. Our answer is 1/2. So in this case, we have a different indeterminate form. So far, let me find the chart again. The first two examples that we saw were both 0 over 0. Sorry, I guess we've done 3 examples of 0 over 0 indeterminate forms, and that's going to be our most common example. But now we just saw our first indeterminate form of a different type, infinity minus infinity. So in this case, we had something that looks infinite minus something that looks infinite. Combining it together allowed us to get some cancellation and get to a point where we can evaluate the limit.